Hi, I'm Atul John Matthew. I'm a graduate student in computer science at Lama University. The topic that I'm going to take a presentation is about managing update conflicts in Bayou, a weakly connected replicated storage system. I'm doing this presentation as a part of my course Advanced Operating System by Dr. Osborne. Coming to the overview of this presentation, we will be going to cover the introduction, which discusses about what is meant by Bayou, why are we using Bayou, its goal, all those things. Next, coming to the topic bioarchitecture. In this, we will give an idea about the architecture of Bayou. After that, we will be covering the conflict detection and resolution. In this, how a conflict will occur, how to resolve this conflict, all these points are discussed. Next, we will be covering the mechanism for conflict detection and resolution. In this, how to handle the conflict and the mechanism used to resolve this conflict are discussed. The next is the replica consistency, which is the basic fundamental property of Bayou. After that, we will be covering the write stability, which shows how a write operation becomes stable, and the storage system implementation issue, which shows implementation issues which are faced in a storage system. After this, we will be covering the authorization which is provided in the Bayou, that is called the access control. Then at last, the Bayou implementation and experience, which shows how the Bayou is implemented and the values are evaluated. And finally, the conclusion and the reference. So, coming to the introduction, what is Bayou? So, Bayou is a cool distributed system. It's mainly used to help to build a distributed system in sort of weakly connected, highly available manner. This paper mainly teaches a lot about some fundamental lessons and how we should build this distributed system in a sort of weakly connected, highly available manner. This figure gives an idea about the Bayou server and how the clients are trying to run the concurrent activities in the Bayou server and how the server is connected to the different servers in the network. All these things you can see from this figure. Bayou is mainly a replicated, weakly consistent storage system which is designed for mobile computing. It includes different portable machines with less than ideal network connectivity. In order to maximize the availability, user can read and write any accessible replica. It can be used in many of the non-real-time collaborative applications, which is at the different host at different time. Let us consider two situations of scheduler, which is the meeting room scheduler and bibliographic database. First, we consider the meeting room scheduler. In this, it allows the user to reserve a meeting room for a given period of time by the different user. For example, at most one person is allowed to reserve the room at a given period of time. Next, when we consider the bibliographic database, it allows the user to add entries to a database. So, it can also be done cooperatively adding the bibliographic entries. In this, the user can freely read, write any copy of database. Each entry has a unique key like John A or John 92. Each key is tentatively assigned with entry is added. With each entry is added, the user must be aware of the concurrent updates and should wait till the key is confirmed. There are different problems which may occur by chance in this bibliographic database. Like the same bibliographic entry may be added by the different user with the different key, or if the system detects these duplicate entries, they will merge these entries into a single entry which is with a single key, like John A 92A or John 92, for example, like that. So it will assign a common key and make these duplicate entries into a single value. So let us check why we are using Bayou. So Bayou is a sort of NoSQL before NoSQL. This paper we will try to solve a lot of challenges. It tries to rethink the system boundaries, which makes the application to perform updates on a system. It also brings the application logic and the system execution. We will learn from our predecessors. It also helps to rethink the application and the boundaries in the system. So there are different goals in the Bayou server which has to be considered. Let us check some of the basic main goals of the Bayou. It is mainly used to build a storage system that will facilitate the need of mobile devices. One of the main goals of the Bayou is to handle the frequent disconnections. So in distributed system network, there is a lot of disconnection since the network is not reliable. So one of the main goals of the Bayou is to handle the frequent disconnections. It is also mainly used to facilitate the conflict detection and resolution. So altogether, we can specify the Bayou as how to build a system which allows the update anywhere but allows the user to easily build the applications. So these are the main goals of the Bayou distributed system. Let us check with the Bayou architecture. In this, the client application will interact with the server through the Bayou API. Like we can see here, the Bayou API is mainly used by the client application to communicate with the server. In this API and the underlying client server, the RPC protocol mainly supports two APIs, that is read or write API. This is the main basic system model of the Bayou. Let us consider much more detail about the Bayou architecture. In Bayou, if we want to update anywhere, there are certain trade-offs in terms of semantic guarantees which can provide the data in the database, and it will guarantee the availability. And it will also guarantee the low latency and the scalability. So there is no need to go over the wide area network or local area network for the service request. And for scalability, it is very easy to add more nodes, and these nodes don't have to communicate with the other nodes. So thereby we can get good throughput. Let us consider the use of anti-entropy. So all we know that entropy is a sort of randomness, or the amount of information in the system is disorder. That is meant by entropy. So what is meant by anti-entropy? Anti-entropy means bringing the order back to the system. So it uses the anti-entropy to exchange the updates between the system. So it thereby brings the order back to the system. so that it helps in shipping and exchanging the operations in a system. Conflict detection and resolution. So what is meant by a conflict? So conflict will occur when two clients simultaneously tries to update the same piece of data in a database. So let us consider an example where two persons simultaneously wants to deposit some money into a particular person's account at the same time on the same day from the different server. In this case, there is a chance there is a conflict is going to occur, like the two person is trying to update the one person deposit some money into a particular person's account at the same time on the same day. So consider an example: if John wants to give Peter $100, if Michael wants to give Peter $100, both are trying to deposit money to the Peter's account at the same time on the same day, both on different servers. So just check if it satisfies to execute this operation concurrently. So the different applications have different notions of what it means for the two updates to conflict. It depends on the applications whether the conflict should occur or not. So in Bayou, the application will define what a conflict means. So it depends on the application whether a conflict occur or not. So in Bayou, there are many mechanisms for conflict detection and resolution. Bayou system has mainly three mechanisms for conflict detection and resolution. There are update function, dependency check, and the merge function. The update function is mainly used for writing. For example, in the previous example that I have said, the update function should be update the Peter's account balance by adding 100, and it should update the Jones account by subtracting the $100. So these are the main that is the main update function that should happen in the previous example that I have said. And considering the dependency check, it checks for any conflicts according to any application logic. It is the precondition for performing the update that is included in the write operation. It checks for the conflict according to any application logic, as I have mentioned here, and it also detects the conflict. So each write operation, including a dependency check on the application supplied queries and expect result. If the dependency check fails, the update function cannot be carried out. So we will go to that merge function if the condition is not passed through the dependency check. If a conflict has been detected, then the function helps to issue a compensation logic for the particular conflict. So that is the main function of the conflict, or function of the merge function. It will provide compensation logic. Let us consider the example which is given, a Bayou write operation, which is having a dependency check, an update function, and the merge function. So the overview, we can see it like, if the dependency check passes the condition, then we will apply the update function. If it not passes through the dependency check, we will use a merge function to carry out the conflict and provide a resolution. So let us consider the one more example, which is like booking a meeting room for a particular time slot on a specific day. So in this example, For the update function, we use to insert booking registry with the month, day and year, and the quarterly meeting, that is the meeting name for the meeting and the time slot. All this data has to be done in the update function. In dependency check, it checks if the meeting room is available on a specific day for the particular time slot. So after the dependency check passes the above example, the update data we can insert into the database of the server, which is directly connected to the Bayou API client. If the dependency check fails in the above example, the merge function tries to find another time slot available on the provided alternatives for the same meeting room. This update got done over in one server. It will ship this update to another server in the network asynchronously. So let us consider another example, which is the money transfer example. Previously we have discussed about the meeting room scheduling example. In this example, we have to transfer a certain amount of money from one account to another account. For example, X to Y. So in update function, it transfers the money $100 to the Y's account, and in the dependency check, it checks whether the X has the $100 in its account, and in the merge function, if there is no 100 balance, it will provide an error log, otherwise it will issue the transfer. So consider the example where X is having $180 and Y is having $25. After the update function, X transfers $100 to Y. So in this condition, dependency check whether the X has $100 in its account. If X has $100, then it will update the function, and then X will become 80 and Y will become 125. Consider one more, like right now the X is having $80 and Y is having $125, and one more account Z which is having $90, and we are trying to do an update function in which X transfers $100 to the Z's account. So in this condition, dependency check will check whether the X has $100 in his account. Here the dependency check has failed. So based on the order in which the operation arrived, then only the transaction will achieve. So here, since the first transaction from X to Y has occurred, so the second transaction X to Z is not possible because the X account is not having $100 balance. So it will basically depends upon the order of events in which the operation has to be carried out. So the main fundamental property of Bayou is replica consistency. In this, every server will perform writes in the same well-defined order so that all servers move towards eventual consistency. The conflict detection and merge procedures are also deterministic. So let us consider about the write stability in Bayou. So write operation becomes stable when the set of writes that precedes it in the server write log is fixed. After writes are finished at some point in the future, we will get some value for every data item on every server. For this, we will decide some stable prefix of writes. So write is stable when it has lower timestamp than all the servers. If after some writes, if a new write comes with a timestamp which is smaller than the previously executed timestamp, in this situation, we have to reset to the initial state of the database and sequentially replay the transaction process in the timestamp order. Consider the example where we have 3 writes executed, which is having 11, 22 and 28. So after some time, a new write which is having timestamp 13 came to execute. So the new execution has to be done in such a way that we have to add the 13 timestamp write into the execution order and re-execute we have to re-execute the data in the newly executed timestamp order. So let us consider the problems which is going to happen in the write stability. So one of the main problem which is facing is very expensive. So as we consider in the previous example, every time a new timestamp comes, we have to reinsert and rerun the program, rerun the execution. So it is causing more expensive. And the other problem with the Bayou write is it makes the garbage collection really hard. So in Bayou, it uses a master server to determine the ordering. So in this, it will designate one server as the master and it will split the set of writes into 2 categories. One is tentative write and the other is committed. The tentative writes which have reached the local server and haven't ordered yet. In this, the writes are not ordered. So initially, when the write is accepted by the Bayou server, writes are ordered accordingly to the timestamp assigned to them by accepting the system. So in the committed write, it has been executed for the last time at the server. Preceding write log is fixed at the server. In this, each write is eventually committed. The writes are ordered according to the time at which they committed and before tentative writes. In this, the timestamp are monotonically, like in this, the timestamp ordering is considered at each server. Let us consider the storage system implementation issue. Bayou's demand on underlying storage system used by server are need for speed efficient write logging, efficient undo redo of write operation, specific view of committed and tentative data, support for server to server anti-entropy. In this Bayou, we have implemented a storage system which has been tailored for these special needs. So let us check what is the storage system which has implemented in Bayou. So this is the diagram which shows the Bayou database organization, which is the storage system implementation. In this we have the tuple store, the undo log, the write log. All these are mainly used in the storage system implementation of Bayou. So these 3 main components which is shown in the previous are write log, tuple store and undo log, as I have said. So what the write log is having. So in write log, it contains the writes that have been received by a Bayou server, and these writes are sorted by their global committed or tentative order. In the tuple store, it is like a database that is obtained by executing the write in the order which is used to process read request. So let us consider the undo log. In the undo log, it facilitates the rollback of the tentative writes that has been applied to the tuple store so that they can be re-executed in a different order, such as when a newly received write gets inserted into the middle of the write log, or when existing write gets recorded through the committed process. So the main purpose of the facilitates the rollback tentative writes that has been applied to the tuple store. So these are the main components of the, it shows the storage system of the Bayou. In order to make sure the server has not reaccepted the same write from the other server during anti-entropy, we have different vectors, that is O vector, C vector and F vectors, just to make sure that the server does not reaccept the same writes from the another server during the anti-entropy process. The write log also conceptually contains all writes which is received by the server. In this, a server can disregard a write from a write log once it becomes stable, since by definition the server will never roll back and re-execute a stable write. A write log mainly actually ordered set of writes containing a tail of committed writes and all tentative writes known to the server. So let us consider the O vector, which is the server maintained. Each server maintains the timestamp vector, which is used to indicate in a compact way the omit prefix of committed writes. The C vector, which characterizes the states of the tuple store after executing the last committed write in the write log. And finally, the F vector, which is mainly used to characterize the state after executing the last tentative write in the write log. So the O vector, the C vector and F vector, which were used for conflict detection, they simply enable the server pairs to identify precisely the set of writes which is need to exchange during the anti-entropy. So let us consider the undo log permits a server to undo any effects on the tuple store of the writes performed after a given position in the write log. So for each new write is received through the anti-entropy, a server inserts it into the write log. Newly committed writes are inserted immediately following the current write set of committed writes known for the server, which may in turn request that some of the writes have been removed from the previously tentative position in the write log. After receiving all writes, the server uses undo log to roll back its tuple store to a state corresponding to the position where the first newly received writes were inserted. It then enumerates and executes all the following writes from the write log, bringing its tuple store and undo log up to the date. So for crash recovery purpose, for the performance purpose, for undo log is maintained only in memory. These are the main specific needs for the storage system implementation. So for the crash recovery purpose, full write log and checkpoint of tuple store are maintained in a stable storage. For the performance purpose, the write log and the current tuple store are maintained in memory. So in undo log, which is maintained, is already maintained in the memory. So in order to make the database recoverable, Bayou stably records the unique identifier of the last write and it reflects in the tuple store checkpointing, making it possible to identify the correct suffix of the write log and makes the write log itself recoverable using the conventional techniques for logging high-level changes to the write log. In Bayou, the authorization is mainly provided through the access control. So in Bayou, because of the minimal connectivity, the assumptions providing access control and authentication has posed interesting challenges. The access control model currently implemented in Bayou has provided the authorization at the granularity of a whole data collection, which is mainly a unit of replications. A user in Bayou may be granted the read or write privileges to a data collection. A user may also be granted several privileges to maintain a replica of data on his workstation or portable computer. For example, let us consider the mutual exclusion and access control is based on a public key cryptography. In this, every user processes a public-private key pair and a set of digitally signed access certificates which will grant the access to the various data collections. So this is how the authorization is provided in the Bayou distributed system. Bayou also uses different types of different types of certificates to grant, delegate and revoke access to a data collection. ACPU PD is the certificate that grants privilege P on data collection, D to the user whose public key is PU. AC certificates are signed by the well-known signing authority. Next, we will consider the D certificate, which is having PU CPY. This certificate is signed by the user whose public key is PY to delegate his privilege encoded in the certificate C to the another user whose public key is PU. And at last, the R certificate, RCPY certificate, is signed by the user whose public key is PY to revoke some user privileges encoded to the certificate. The user whose public key is PY must also have originally signed certificate C. So let us consider about the Bayou implementation and experience. So the implementation of Bayou system has two distinguishable components, which is client step and the server. So let us consider the server step first. The client step first. The client step is a runtime library linked into the application that uses the Bayou for the storage management. It also provides several mechanisms for server location, session guarantees, secure session, read and write operations, and miscellaneous utilities. The server implements the Bayou storage system includes the Mechanism for conflict detection and resolution, server-to-server communication, and the persistent database management system. So these are the basic distinguishable components for the Bayou implementation experience. The performance, next we'll consider what all factors which are affecting the performance of the Bayou. The performance of the Bayou mainly depends on several factors such as the schema of data being used, the amount of data being stored at the server, the location of the client and the server, the platform at which the components are running. These are the specific factors in which the performance of Bayou depends. So while coming to the conclusion, we can say that the Bayou is a storage system which is mainly used for mobile applications that is relies on only a weak connectivity assumptions. So Bayou, let us consider about the advantages which is present in the Bayou. They are the clients can read and write to any replica without any explicit coordination. These data are highly available, so the Bayou will not mark conflict data or system unavailable. It also provides support for clients that may choose to access the stable data. It also gives more general techniques such as dependency and merge procedures, which I have explained in the previous slides. So the dependency checks gives whether there is any conflict is present in the data in the specific write operation, and merge operation will provide an alternative step if the dependency check fails for the specific write operation. The main disadvantage for the Bayou distributed system is its expensive merge procedure. So as I have told, if a new transaction or process with the timestamp which is having less timestamp order than the previously executed or lastly executed one came, so we have to insert the new write operation which is having the less timestamp order, and we have to rerun all the client process again. So this is little bit expensive. So this is one of the disadvantages of the Bayou distributed system. So these are the references that I have covered in this topic. And thank you for listening to this presentation. I hope everyone has understood what is meant by the Bayou, why are we using Bayou, and what are the main goals which the Bayou is providing, and the different Bayou main architecture, which gives an idea about the architecture of the Bayou, and how the conflict will occur and how to resolve the conflict in the Bayou distributed system. And this presentation also gives an idea about the mechanism for the conflict detection and resolution in the Bayou system, and how to handle these conflicts, and the mechanisms which are like the dependency check, the merge function, and the update function, which are used to resolve the conflict. And it also shows how a write operation becomes stable, and how to implement the Bayou distributed system, storage distributed system, All these topics I think everyone should understand, and it also teaches how to build a distributed system in a sort of a weakly connected, highly available manner. I hope everyone has understood all these topics. Once again, thank you for giving patience for listening to this presentation. Thank you.